Hello students, how are you all? I hope you're doing extremely well. So till now we have done about what is metallurgy. Metallurgy is the study of extraction of metals from their ores. Then we have seen what is the difference between a metal and an ore. And we have also seen what are the types of ores. Now very important in the topic is the steps in the extraction of the metal from their ores. There are various steps which need to be followed for anybody who is, manufacturing the metal from the ore. Okay, so let us see what are the various steps in detail. So steps in the extraction of metals from their ores. There are 4 steps. Number 1 is concentration of the ore. Concentration of the ore. Now we know that these ores are present in the earth's crust. So when they are taken out, from the earth's crust, there will be, sand, there will be other metals with them, there will be some, mud, all this along with the ore. Yes. So it is not in the pure form. It has to be concentrated before going into the next step. So just like you have, these concentrates of juice concentrates, you can have lychee concentrate, or you may have, mango concentrate. Now that concentrate, what do we do when we have a party at home? We take a little of it, and according to the number of people, we add water because it's a concentrate. So we add water to it, and then we make it into a proper juice of the right consistency. Right? Similarly, here the ore which we are getting from the earth's crust is not completely pure. It has with it, the humus, then it may have some dust particles, then it will have sand along with it, then it may have other metals with it. So it needs to be concentrated. So that is the first step. First step is concentration of the ore. It is nothing but removing all the impurities from the ore. The ore has impurities, and that needs to be removed so that it is in the pure form. So that is the first step. Then second step would be conversion of the ore to the oxide from sulfide or carbonate ores. Now we have seen there are 4 types of ores. We had the oxide ores also. We had sulfide ores. Then we had carbonate ores and halide ores. Now here we are talking about sulfide and carbonate. Now we cannot get the metal from the sulfide or carbonate ores easily. So what is to be done? They need to be converted into their oxide ores, okay, before we get the metal. Then reduction of the oxide ore. Once all the sulfide ores, if we are taking a sulfide ore, it is converted into oxide ore, and then we are talking about getting the metal from that oxide ore. So that process is known as reduction. So reduction is what you've done about oxidation, reduction, redox reactions. Reduction is removal of oxygen. Okay, when oxygen is removed, removal of oxygen. So it is called reduction of the ore. Then finally, it is still after all these also there will be some, fine impurities in the metal which is obtained. So the refining of the metal has to be done, because every time whenever metal is extracted, they are looking for 99.9% pure metal. Not that it's 90% pure, no. 99.999% pure it should be. Maybe 0.1 or 0.0001, if it is impure, it's okay. But then 99.99% pure metal issue they are looking for, whoever is extracting or whenever we are extracting. So refining of the metal is the last step. So if you see this flow chart, this is extraction of the ore. It is a flow chart which helps you to easily remember all the steps. So you can remember it as a flow chart. Once we do all the steps, we can come back again to the flow chart and see how easy it is to remember. So there are 3 categories here: extraction of metals which are high in the reactivity series. Now again, reactivity series, you all know about the reactivity series. If we go and see, potassium, more reactive than sodium, potassium, sodium, calcium, aluminium, magnesium, then zinc, iron, and then we have tin, lead, tin, and hydrogen. And then we have copper, silver, gold, platinum. So this is the reactivity series. So those metals which are high in the reactivity series, high is potassium, sodium, calcium. They are high in the reactivity series. Okay, so they are obtained by electrolysis of their molten ores. Fine. Then metals which are in medium in reactivity. Medium in reactivity, we're talking about zinc, iron. Even these we consider to be as high only in reactivity. So we have zinc, iron here, or even lead, till lead. Okay. Then least reactivity series, we have copper, mercury. They are least reactive. High reactivity, we're talking about potassium, sodium, calcium, aluminium, magnesium. So all these are high in the reactivity series. So if we want to extract potassium, sodium, calcium, aluminium, or magnesium, we will follow this procedure. If we want to extract zinc, iron, lead, then we follow this second method of extraction, the various steps. And then the last one would be for the metals which are least in the reactivity series. I repeat, there are 4 steps in the extraction of metals from their ores. First step is concentration of the ore. Second one is conversion of the ore to the to oxide from sulfide and carbonate ores, because it is easy to get the metal from the oxide ore. Yes. Then third is reduction of the, now we have got the oxide ore. Now I want the metal. So what is the procedure or the step used? Reduction of the oxide ore to get the metal. Fourth step would be refining of the metal. Now do not worry, we'll be going into each and every step in a little detail. Now we have a flow chart here. What is the use of the flow chart? Flow chart gives us a picture of how the metals in the reactivity series, we know that there are some very reactive metals, some least reactive. So the ones which are on top of the reactivity series, they are extracted using the first steps, okay, in the high in the reactivity series. And the ones which are in the middle, zinc, iron, lead, for those metals, for the extraction, we use the second column in the flow chart where these steps will be involved. And the third column in the flow chart indicates the steps for the extraction of metals which are low in the reactivity series. Then silver, gold, and platinum, generally they are found in the free states. Silver, although it may be in the combined state, but gold and platinum, definitely they are in the free state. They exist in the free state, so only a little refining is required for them. Otherwise, you don't have to go through all these steps for those two metals, because they do not react. No? They do not react with oxygen or carbon dioxide or the sulfur present in the air. So they can be obtained naturally. Fine. Nothing would be confusing. We will go into each step in detail. So let's go and see the steps in detail. Now we'll see step number 1. What is step number 1? Step number 1 is the extraction of metals, concentration of the ores. Now concentration means we want the ore, okay, ore to be purified, to be pure first. It should not have any impurities. So the impurities which are present, impurities in the ore or along with the ore are known as gangue. It's a term given for the impurities present in the ore. So every ore has certain impurities. These impurities are known as gangue. Now we have to remove this gangue. We have to remove this gangue. Let's use the term again, gangue. What is gangue? Gangue is the impurities present in the ore. So we have to remove the gangue to get a concentrated ore. So the gangue or impurities needs to be removed from the ore. Okay, so there are various procedures, various ways, methods to remove these impurities from the ore, the gangue from the ore. So what are the impurities first? The impurities such as sand, stones, silicates, etc. They are, they are present along with the ore. They are sticking to the ore. Okay, or there may be other metals, not only metals, other ores also, which are again present along with the ores. So we want an ore. If I take an oxide ore here, if I take hematite, if I take Fe2O3, I want hematite in the pure form before I start the extraction of iron from it, right? So I'm going to concentrate the ore. So what are the various methods depending on these impurities? What type of impurities are they? Whether there are magnetic impurities or whether there are impurities which are heavier than the ore, or if the impurities are, they are soluble in some reagent, or we can also see if it is a sulfide ore, we use the froth flotation process. You don't need to go into the details of these methods, but you should know what they are. Okay, so one is hydraulic washing. Hydraulic washing is the ore is washed nicely with a strong jet of water. So what happens is all the impurities, these impurities will be removed with the water and the pure ore remains. Okay, you don't need to go into the details of it. Hydraulic washing, washing here means with water. So what happens here is the impurities get washed away with the with the water, and the pure ore remains behind, which can be collected. A jet of water is poured on the ore. When I say jet of water, it is with full force, lot of pressure. Okay, so then what happens? All the impurities associated with the ore, which are present with the ore, the sand, limestone, silicates, all that, what happens is they get washed away. The ore doesn't get washed away. The ore will not get washed away. These impurities get washed away because the ore is heavy. So it will remain, uh, or it can be obtained in the pure form once all these impurities are washed away. Second is the froth flotation process. This is generally used to purify sulfide ores. To purify or concentrate. Let's use again this word, to concentrate. Concentrate sulfide ores, we use froth flotation process. Again, a few years back you had this in detail, but now CBSE does not have anything in detail. So froth flotation, again, they used to have a tank, and in that tank they would have the water, and on top of it a little oil was present, and then the ore is also present here, and again with great pressure the air was allowed to be blown in, air with great pressure. So what happened was the all the impurities would stick to the oil, and the ore would remain at the bottom. A froth would be formed. There would be a big froth like foam, foam would be formed, and the ore would remain in the froth, whereas the impurities would stick to the oil, and it could have been removed. Then once the froth settles down, then the ore would be collected. So this is known as froth flotation process. Mainly used for sulfide ores, mainly used for the concentration of sulfide ores. I repeat, concentration is purifying of the ore, removing the impurities of the ore, removing the gangue from the ore. Okay. Then the third procedure is leaching. Leaching is the ore is soluble in a reagent. This is generally used for the bauxite ore, which we have seen, bauxite, aluminium ore. Okay. The bauxite ore is Al2O3, 2H2O. So for this ore, leaching is used because this is soluble in sodium hydroxide, but the impurities are not. Impurities present in bauxite are not soluble in sodium hydroxide. So then they can be, that we can separate it. It's something like sand in water. So I can separate the sand in water. Similarly here, the bauxite is soluble in sodium hydroxide, but then the impurities are not, so they can be separated. Then magnetic separation, as the name indicates, magnetic. So these are used for iron ores. So for any iron ore, the ore is passed through this magnetic rollers they have. So as the ore is passing, the impurities will remain on the magnetic wheel, whereas the ore will start sticking to the magnetic wheels and it drops down. Okay, the wheels are magnet. So this magnetic belt is there. So the ore is allowed to pass through. Impurities will not stick to the magnet, but the magnetic, because the iron ores, they can, or they are magnetic in nature. So they stick to these wheels on the belt and they can be collected later on once it stops moving. They fall down. So that way magnetic separation is used for iron ores. So these are the methods of concentration of the ores. Concentration of the ores is removing the impurities from the ores. So concentration is done to remove the impurities from the ores. The concentration of ores is also known as enrichment of the ores. So what are we doing? We are enriching the ores. Removing impurities means the ore has become enriched. The ore has become pure. The ore does not have any more gone or gang into it. Okay. Process of concentration depends upon their physical and chemical properties. So which method to use will depend upon what are the impurities present with the ore. Whether to use hydraulic washing or froth flotation or leaching or magnetic separation will depend upon what are the impurities that are present with the ore. Depending on that, one of these methods is selected. So this is the first step. First step, concentration of the ore, removing the impurities present in the ore. The impurities are known as gangue. This process is also known as enrichment of the ores. Okay, so at least remember the methods. You don't have to explain the methods. You can just remember the methods, and the methods will depend upon the type of impurities which are present with the ore. Great. Okay. Let's go to step 2. Step 2 in the extraction of metals from their ores. Now we have got the concentrated ore. Step 1. From step 1, what have we got? We have got concentrated ore, enriched ore. So concentrated ore is the ore which does not have any impurities. The concentrated ore is ore which does not have any impurities. So we have got the concentrated ore from step 1. So next, what do? We have to convert. Now comes the conversion method. Conversion of the carbonate and sulfide ores to oxide ores. Conversion of carbonate and sulfide ores to their oxide ores. Why should we do this? I have told you, because it is easier to get the metal from the oxide ore rather than from the sulfide or carbonate ore. it is easier to get the metal. It is easy to obtain the metals from their oxide ores rather than from their sulfides or carbonates. So they need to be converted. If it's a sulfide ore, it has to be converted to the oxide ore. If it is a carbonate ore, it has to be converted to the oxide ore. Now, how is it done? There are two methods. First is calcination. Calcination is if the ore is a carbonate. Okay, ore is carbonate. Then we use the method of calcination. So calcination is nothing but heating of the carbonate ores in limited supply of oxygen to convert them into oxides. This process is known as calcination. Students, these two methods are very, very, very important. Okay, so calcination is a method to convert the carbonate ores into oxide ores. So how is it done? The carbonate ore is heated in limited supply of air. Air here we're talking about oxygen. Limited supply of oxygen, the carbonate ore is heated. So look here, zinc carbonate, when it is heated, you get zinc oxide plus carbon dioxide, which is released. So now we have got the oxide ore. Yes, from the carbonate ore. So this way, the carbonate ore is converted into the oxide ore by a process known as calcination. Then the next method is if the ore is a sulfide ore. If the ore is sulfide ore, we conduct what is known as roasting. Now, roasting, you all are familiar with this term. Roasting, chicken roast. You all like to eat, no? Chicken roast. Yes. So, it is just roasted and roasted in a lot of oxygen. A lot of fuel is used for roasting. So, heating of the sulfide ores in the presence of excess of air is known as roasting, and in this way we are converting the sulfide ores are converted into their oxide ores. So zinc sulfide plus oxygen, we are providing oxygen, heating zinc oxide sulfide in a lot of oxygen, in a lot of excess of air to convert them into oxides. Okay, so zinc sulfide plus oxygen, lot of heat provided, and it forms zinc oxide plus sulfur dioxide. Okay, so this way the sulfide ores are subjected to a lot of heat, or they are heated in excess of air to convert them into oxide ores. Okay, and this process is known as roasting. This process is known as roasting. Here you can take one more example. Calcium carbonate is heated in again limited supply of air to form calcium oxide plus carbon dioxide. Here you can take similarly copper sulfide plus oxygen will give copper oxide plus sulfur dioxide. Okay, so this way we will get the oxide of the metal. Oxide of the metal will be obtained here, and we can get the metal from the oxide easily. So I repeat, step number 2 is conversion of the carbonates or sulfate ores to their oxide ores. There are two methods. If it is a carbonate ore, we use the method of calcination. Calcination is when the ore, carbonate ore is heated in limited supply of air to form the corresponding oxide ore. Then roasting is heating of the sulfide ore, heating of the sulfide ore in excess of oxygen to form the corresponding oxide. Okay, so you can remember at least 2 examples. So what have you learned till now? We have learned about minerals. We have learned about ores, the difference between minerals and ores. Then we have done the steps in the extraction of metals. We have done 2 steps. There are 4 steps. We have done concentration of the ore. Okay, concentration of ore. That means removal of gangue. Gangue is impurities present in the ore. Depending on the type of impurities, there can be 4 methods: hydraulic washing, froth flotation process, then magnetic separation, and leaching. Then the second step was conversion. Conversion of carbonate or sulfide ores to oxide ores. Oxide, why? Because it is easy to get the metal from the oxide ores. Now, if it is a carbonate ore, calcination is done. Calcination is heating the ore in limited amount of air to get the oxide ore. Calcination, and then the oxide ore is obtained. Then sulfide ore, we use the process of roasting. Roasting is, every time you listen to roasting, think about, the chicken being roasted, or you have, some paneer and also roasted after it is marinated and all, they roast and give it. So even potatoes can be roasted. So sulfide ores, roasting. Roasting is heating of the ore in excess of air and then getting the oxide ore. So these are the 2 steps we have seen, and we have come till the oxide ore. Now we will go and see what is the 3rd step and then the 4th step. So till we see those steps, try to sync whatever we have learned, try to get it and register it. Read the chapter so that you can follow it better. And then when you go and see the next 2 steps, you're already familiar with the first 2 steps. Okay. So till we do the next steps and we continue our journey, till then, this is Usha Mangipudi signing off.